My name is Caitlin Carter. I have a Bachelor of Education in Adolescent and Young Adult Integrated Science and work as a librarian in Toledo, Ohio. I am pursuing a Bachelor of Science in Software Engineering.
My name is Christopher Moore. I'm a first year for biomedical engineering. I have an associate's degree in biomedical equipment technology, and I'm an Air Force veteran.
I am Art Martinez from Toledo, Ohio, retired Army engineer. I have a bachelor's in business. This is my first year in electrical engineering at ASU, and I'm working towards a professional license in electrical engineering.
As conservationists adopt digital platforms for educational outreach, there's a growing need for robotic solutions to promote audience engagement. Wildlife conservation organizations are appealing to broader audiences through streaming platforms with the hope of helping people build personal connections with animals and the environment. One long-standing approach has been to place cameras in an animal habitat and stream the live feed online. However, these static camera views do not retain engagement in the modern online attention economy. Additionally, much of the live streaming equipment on the market is not suited for use beyond a typical studio environment. Our proposed solution, the Sanctuary robots, are designed with animal care and live streaming in mind. Each robot is designed to move about animal habitats and easily integrate with streaming platforms.
The proposed robot team by Sanctuary Robots is the PooBot, the Night Moves Bot, and the Treat Bot.
This is the PooBot. It scans using a gas sensor. Waste is scooped and dumped in a designated zone when full, indicated by a force sensor. Waste zone is indicated by an RFID tag. Picture to the left on the slide is the wiring diagram. Picture to the right is the logic diagram that shows the way this robot has been programmed using C++.
The Night Moves Bot is a cable-suspended robot that allows observation of animals in their habitats. The robot receives signals from a remote control through the IR receiver. A DC motor drives two wheels, which move the robot left or right along the cable, and a servo motor mounted below rotates the position of the camera and microphone. Ultrasonic distance sensors on either side of the robot can override user input to prevent collision.
TreatBot remotely dispenses treats after an in-chat command is sent. It has three sensors: a tilt sensor that stops operation if the lid is open, an ultrasonic distance sensor that constantly measures treat level, and an ultrasonic distance sensor that acts as an animal proximity sensor, prompting chat if an animal is nearby. It has one rotation servo that moves 45 degrees once it receives a prompt. Here's a brief overview of the flowchart and circuitry of TreatBot.
The Sanctuary robots work together to collect and remove animal waste, allow remote viewers to dispense treats for animals, and move cameras around the habitat to observe animals discreetly. When enabled, the PooBot moves around the habitat following a pre-programmed pathway. When the gas sensor detects waste, the PooBot will scoop and lift the waste into its dump body. At the end of the programmed pathway, or when the PooBot senses that the dump body is full, the robot will return to the waste zone and empty the dump bucket. When the robot senses that the battery is low, it will move to the docking station to recharge. When the Night Moves Bot receives a move signal from end users, it will move either left or right along the suspended cable. When moving, the ultrasonic distance sensors will override move commands as needed to prevent collisions. End users can also signal the Night Moves Bot to rotate the camera and microphone mounted at the base of the robot. When TreatBot receives signals, the treat wheel inside will rotate, dispensing treats down the chute to the bowl inside the animal enclosure. When the robot senses that the treat level within the hopper is low, it will illuminate an LED and cease treat dispensing until it has been refilled. When animals approach the TreatBot, it will send a signal out to end users to suggest that a treat may be dispensed.
TreatBot offers a standardized solution that can be equipped to all animal enclosures, increasing potential revenue stream. NightMoveBot goes away from the static camera system that Alveus currently has and allows more audience engagement with a camera system they can control after a donation, increasing revenue stream and audience engagement. And PooBot automates the enclosure cleaning process, allowing Alveus staff more time in the studio. In conclusion, Sanctuary Robots addresses two core challenges at Alveus: limited remote audience engagement and time-intensive habitat maintenance. Our array of three specialized robots, the Night Moves Bot, TreatBot, and PooBot, delivers practical and scalable solutions that enhance viewer experience while freeing staff to focus on education, outreach, and animal care. Thank you.